Hello, and you're welcome back to my channel. Thank you for stopping by. Today, we'll be answering a question on circle theorems. Now, when we talk about circle theorems, we're talking about angles that are inscribed in a circle. There are some certain rules governing how you answer questions that relate to angles in a circle. Now, the very first question you've been asked to answer here. Let's read through the question though. This is the diagram. I know it looks daunting. I know it looks, oh my, what is this? But please don't be perplexed. We are going to break it down and we would answer these four questions. We're going to look for ADC, AOC, BAT, and OAB. Stay with me. Now, I would advise that you answer these questions in this order because most likely this is the easiest way to answer this question. Let's read the additional information given here. We are told that A, B, C, and D lie on the circle. A, B, C, and D lie on the circle. That's important. We're going to learn that very soon. TA is a tangent to the circle at A. So TA, this line here, is a tangent to the circle at A. Very also important. Angle ABC is 131 degrees. That is, angle ABC is 131 degrees. And angle ADB is 20 degrees. ADB is 20 degrees. Now, let's break this down. There's some things that were not stated here that we just need to look at ourselves. First and foremost, this is the center of the circle, and this is the circumference of the circle. Since this is the center and this is the circumference, this spot here, A, is going to be, OA is going to be a radius. Because any line that starts at the center of a circle and goes down to its circumference is a radius. Bear that in mind. We're going to use it pretty soon. In the same vein, OC is also a radius of the circle. Now, the very first question they've asked us to answer here is, what is angle ADC? It means they're asking us for this angle, this entire space here. Now, if you look critically at this diagram, notice that we were told earlier that ABC lie on the circumference of the circle. If you look critically at ABC, you will notice that ABCD form a quadrilateral. ABCD form a quadrilateral. It forms something that looks like this. Let me do a quick sketch here so you could see it. So you have your A, your B, your C, and your D. You see, it's a quadrilateral. And we have this theorem about cyclic quadrilaterals. What's a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral that its vertices touch the circumference of the circle. If the vertices of the quadrilateral touch the circumference of the circle, we have a cyclic quadrilateral. What is important about a cyclic quadrilateral? The opposite angles of a cyclic quadrilateral are supplementary. Let me say that again. The opposite angles of a cyclic quadrilateral are supplementary. What does supplementary mean? It means they add up to 180. So to our brief sketch here, the angle at A is opposite to the angle at C, so they should add up to 180. In the same vein, the angle at B is opposite to the angle at D, so they should add up to what? 180. Now, take a look at this. The angle at B is 100 and what? 31. So the angle at D should be supplementary to it, like we said here. So angle ADC plus 131 should give us 180 degrees. So ADC will be equal to 180 minus 131, and that will give us what? 49 degrees. So we now know that our angle ADC is what? 49 degrees. All right, now to the next one, AOC. AOC AOC. The angle is at the letter in the middle, so they're referring to this angle now. AOC. Now, if you take a look at angle AOC, and let's go back to our previous angle ADC. You know, this is AC here. Let me put a dotted line there. What we call this my dotted line that goes from A to C? It's called a chord because it's a line that goes from the circumference to another end of the circumference. Now, this particular chord is creating a segment. All right. Now, this particular chord again is creating angle AOC at the center and angle ADC at the circumference. Did you notice that? This same chord is creating the angle AOC at the center and angle ADC at the circumference. Now, another circle theorem states that angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. The angle at the circumference here, we just found it out to be 49. So our AOC is actually, sorry about that. Let me take that out. It's an angle, not a vector. Angle AOC is twice angle ADC. So AOC will be what? 2 times 49, and that gives us 98. So AOC is what? 98 degrees. Up next, we need to answer BAT. Let's look out for BAT. Well, BAT, it's this angle here. Okay, now this angle here is being made with a tangent that is external to the circle. But there is also a theorem that talks about this particular angle being created with a tangent. It's called the alternate segment theorem. What do we mean by an alternate segment? Remember, this is AB here. AB is a chord, and the chord will split a circle into 2 segments, the minor segment and the major segment. So the minor segment is this portion down here, and the major segment is the rest of the circle. The theorem states that the angle in the minor segment here is the same thing. The angle made by this minor segment and the tangent is the same thing as the alternate angle in the rest of the major segment. This is what I mean. This angle here is the same thing as this angle here. Why is it just this angle? Because it's between AB, not AC. If it were AC, it would be the entire angle D. But since it is with AB, it is just this portion. And what's this portion? It's given already. It's 20. So your BAT is 20 degrees. Based on what? The alternate segment theorem. And finally, angle OAB. Angle OAB. If you take a look at angle OAB, OAB, this is just the rest of this angle here. This is angle OAB. Angle OAB seems to complete the angle between OAT. And what's angle OAT? It's a right angle. Why? The angle between the tangent and the radius is 90 degrees. Your tangent will always make 90 degrees with the radius of the circle at the point of the tangent hitting the circle. So this entire angle here is 90. We just found that this portion BAT is 20. So what would this portion be? It's going to be 90 minus 20, which will be equal to 70 degrees. So our angle OAB is 70 degrees. I know it's a lot to take in one video, but you would find other videos on my page on how to answer a question on circle theorems. Please go over them. Thank you for watching and see you in the next one. The next question we'll be taking is question 14, rearranging the formula to make one of the variables the subject. See you in this one later.